Hi guys, I was having a chat last night with Arunas and Matt and Grum, and just talking about the different designs and all the rest of it. And I've built, geez, about I don't know, 5 different rotors so far, all sorts of configurations. I had one of these. Direct drive to the motor, drew way too much current, and then the thing flew off and yeah, nearly decapitated me. What else happened? I used a few different rotor designs. This was one. I screwed my or bolted, I should say, the steels to there, and that was sitting there, and then just the incredible cogging that I was getting, just couldn't turn it. Incidentally, that's, you know, not magnetic. And what else? There was another one I tried. Oh yeah, there was one that I tried with a CD HDD platters and an axle and a flat. Basically replaced, removed that rotor, put this disc in there, had some magnets and held on by magnets on the other side. That was the rig I was using for that, with an axle through the centre, and so that was sort of on the horizontal rather than the vertical like this one is. But in all of those designs, the cogging was just unbelievably difficult to deal with. For some reason, the plastic one doesn't cog anywhere nearly as badly. Incidentally, I haven't got this tuned properly. You can see we've got a gap there, which is way too big. Between our steel and our magnet. If you want something to focus on, if you've got questions about what things are important, I would say definitely getting your steels as close to your magnets as you possibly can. For a vertical rotor like this, or perpendicular, whatever you want to call it, I think a curved, embedded steel, something like this, would be the trick, because then you're not high on the corner when you're coming in past the magnet. Or if you can get some nice curved magnets, that'd be good too. And then you've just got the top point there, which is as close to the magnet, and the corners are out of the way. My first design was actually similar to that. These I can't get close enough. Just because of the sharpness of the curve. You know, to get closer, it's your corners are always going to hit these mags. So I've got to either get new steels there. Graham asked last night about ferrites. Yeah, I've used the ferrites. Nah, forget it. And Matt and Arunas both were saying that because the pole needs to flip really quickly, that they just won't do it. But yeah, my experience is that laminate steel is the way to go. I've tried all the other different materials. Haven't got back to the voltage or the amperage, even though I didn't measure it. But you know, when I was lighting one of these, got these lit fairly brightly actually. So what I've decided to do is go back to the original design and see if I can modify it a little bit. I've just been tinkering with it now, but we're still about a factor of 7 of where I was the first time I built this, and that's mainly because these steels aren't as close to the magnets as possible. Arunas did point out that one of the problems with my cogging in this particular design was probably because I had opposing magnets or opposing fields. So I've got the same field facing with the magnets on the inside here now. Anyway, I just wanted to let you know. Don't have anything to show, but I just wanted to let you know in case any of you are having questions about what to use and what problems you might encounter. All right, talk to you later. Bye.